Hello friends, today we will learn about complex numbers and square root of complex numbers. Let us consider a complex number a plus ida b. So the square root of complex number a plus ida b will also be a complex number that is called x plus ida y. So basically we need the value of x and we need the value of y. Once we determine the value of these two, we will determine the actual square root of complex number a plus ida b. So first of all, to solve this equation, we will squaring the both sides and we get a plus ida b is equal to x plus ida y whole square, which will be equal to x square plus ida y square plus 2x ida y. Solving further, x square minus y square plus 2x ida y. Since two complex numbers are equal, so we know the property of complex numbers that the real part of one complex number is equal to real part of second, and hence a will be equal to x square minus y square and b will be equal to 2x y. To solve this, we also need a square plus b square, which will give us x to the power 4 plus y to the power 4 minus 2x square y square and square of this, which is 4x square y square, which will give us ultimately x square plus y square ka whole square, and the root of this, which is actually the modulus of our main complex number, will be equal to x square plus y square. Now consider two things: equation number 3 plus equation number 1 and equation number 3 minus equation number 1. It will result in root of a square plus b square plus a, which will ultimately be 2x square, and root of a square plus b square minus a, which will be 2y square. So now we can get the value of x as root a square plus b square plus a by 2, and y as double root a square plus b square minus a divided by 2. Now the sign of x will be positive, but the sign of y will depend on the sign of this b. So we can write signum of b. So finally, when we have a complex number z which is equal to a plus ida b, the root of z x plus ida y, we will get root of z as plus minus x plus ida y, because a square root always gives us plus minus of other complex numbers, and we get the value of x previously as root of a plus root a square plus b square divided by 2, and the value of y as root of a minus a plus root a square plus b square divided by 2. Here we have the sign of x as sign of a, but we don't have the sign of y as sign of b, so we will use mod b by b, which will give us the sign of y as the sign of b, and this is the signum of b. Now we'll learn about cube root of unity. We know that, consider this equation, x to the power n is equal to c. If I ask how many solutions we have here for x, as we know that x is equal to c to the power 1 by n is obviously a solution, but it's not the only solution. If we consider this thing x to the power n equal to c, we know fundamentally that x has n solutions, but all those n solutions are not real, and we need to use complex numbers to get all those other n minus 1 solutions. Those n minus 1 solutions may be real, may be complex numbers, but these can be found. So here this concept will be used to get the cube root of unity. To get the cube root of unity, we need this equation, x cube equal to 1, because cube root of unity 1 by 3 is x. So solve this equation by x cube minus 1 equal to 0. Factorizing it, x minus 1, x square plus x plus 1. Clearly this factor gives us our answer x is equal to 1, which is real. Hence the leftover two solutions will be complex solutions, and which will be determined by this equation. Solving this equation, x square plus x plus 1 equal to 0, by determinant method we get x is equal to minus b plus minus root के अंदर b square minus 4ac by में 2a, which will be minus b square 4ac by 2, which will result in minus half plus minus iota root 1 minus 4 minus 3 by this will turn minus 1 plus minus iota root 3 by 2. There is a property about complex numbers that when we rationalize the things, if we have three solutions here and we get one of the solution real and two solutions complex numbers, then those two solutions will always be conjugate of each other. If we have two n solutions which are complex, then those n solutions will be conjugate to the other n solutions. Since we got the value of x as minus half plus minus iota root 3 by 2, let's split it. Minus half plus iota root 3 by 2, consider this as omega. So now minus half minus iota root 3 by 2 will automatically be omega square. This is because we have two characteristics of cube root of unity. First of all, omega and omega square both are conjugate to each other, which I stated earlier. And second, the square of one root omega will result in the second. It means the square of omega square which should be result in the first, that is omega ki power 4 is equal to omega. This is because we know that omega is a cube root of 1. So omega cube must be 1 and omega 4 must be omega. Now we have all the three roots of unity, which is 1, omega and omega square. These follows three basic properties of cube root of unity, that is omega. The first property is the sum of all the three roots 1 plus omega square is 0, because 1 value of omega is minus half plus iota root 3 by 2 and omega square is minus half minus iota root 3 by 2 is clearly equal to 0. The second property is already stated that if we have two imaginary complex numbers as roots, then product of one, then a square of one which will result in the other. And the third property is if we multiply the two complex numbers omega and omega square, then this should result as 1, because which is a standard form.